Hello everyone, and welcome to today's webinar in the CERDP and ESTCP webinar series. My name is Rula Deeb. I'm a Senior Principal at Geosyntac Consultants in Oakland, California. I'm the coordinator of the webinar series on behalf of CERDP and ESTCP. I will be facilitating today's call. This webinar will consist of a brief overview of CERDP and ESTCP by Mr. Timothy Petrol, followed by a list of upcoming webinars in the series. After Tim's opening remarks, we will transition to the technical portion of the webinar. Today's event features two presentations on DoD water conservation efforts. First, Ms. Catherine Ostapuk from Navy Region Southwest will provide an overview of water policy, regulations, and current challenges facing military installations in regions with scarce water resources. Her presentation will be followed by a brief Q&A session. Second, Mr. Gary Angiano from NAVFAC XWIC will discuss the findings of an ESTCP-funded project on innovative acoustic sensor technologies for leak detection in challenging pipe types. His presentation will also be followed by a Q&A session, and we will conclude the webinar with an interactive Q&A between our two speakers. Today's broadcast will be listen only. You may submit questions by using the chat box on the left-hand portion of your screen. You do not need to wait until the Q&A period to submit your questions. In fact, we do encourage you to submit questions in advance of the Q&A session. On this slide, we have provided a few suggestions in the event that you experience difficulties with the broadcast audio. Typically, any delay will be fixed if you refresh your screen or call into the conference line. However, if you continue to have problems, please submit a comment using the chat box in the lower left corner of your screen. With that, I would like to introduce Mr. Timothy Petrol, who is the ESTCP Program Manager for Energy and Water. Before joining CERDP and ESTCP, Tim worked at the National Renewable Energy Lab, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim?
Thank you, Rula, and welcome everybody to today's CERDP and ESTCP webinar. CERDP is the Strategic Environmental Research and Development Program. It was established in 1991 by Congress as a partnership between the DoD, the Department of Energy, and the EPA. CERDP's mission is to identify and address high-priority environmental science and technology opportunities that focus on DoD requirements. CERDP funds both fundamental research as well as advanced technology development that ultimately impact real-world environmental management. ESTCP is the Environmental Security Technology Certification Program in which we demonstrate innovative environmental and energy and water technologies. These investments capitalize on past investments under CERDP or other research programs and are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. Excuse me. CERDP and ESTCP are complementary programs with much of CERDP research occurring in the lab and in pilot scale with occasional field efforts, while ESTCP demonstrations are primarily at the pilot and field scale, although occasionally the supporting lab efforts are conducted. There are 4 program areas in CERDP and 5 in ESTCP. The Energy and Water program area is only in ESTCP, while the other 4, environmental restoration, munitions response, resource conservation and climate change, and weapons systems and platforms, are both CERDP and ESTCP programs managed jointly by the designated program manager. Energy and Water, today is our webinar is focused on energy and water, and we focus on research and demonstrations that were conducted in the Energy and Water program. The Energy and Water program supports a variety of demonstrations of innovative technologies, primarily in 3 areas of research: smart and secure installation energy management, which include microgrids, energy storage, and methods for participating in ancillary service markets. 2, efficient integrated buildings and components, which includes a broad array of energy and water technologies. And 3, distributed generation, which covers technologies that provide powers to buildings, support microgrids, and help DoD achieve its energy goals. Today's webinar will present results from a project funded under Efficient Integrated Buildings and Components area of research, and it will be preceded by a presentation on water policy and regulations relevant to military installations. Our webinar series will be highlighting research and demonstration efforts from the 5 program areas. As you can see, our webinars will cover a broad range of topics, with upcoming topics covering use of geophysics for site characterization and remediation monitoring, environmentally acceptable alternatives to fast cook-off testing, and redox-based groundwater remediation technology. The next Energy and Water webinar will be on October 6th on cybersecurity and the impact on installation energy management. You can find detailed information and register for upcoming webinars at this link. And thank you for attending, and I hope you enjoyed today's webinar. And Rula, back to you.
Yeah, thank you, Tim. It is now my pleasure to introduce Ms. Catherine Ostapuk, who is the Legislative and Regulatory Affairs Coordinator for RDML Rich Commander Navy Region Southwest. Catherine is also the Department of Defense Regional Environmental Coordinator for US EPA Region 9. Her role involves providing advice on multimedia environment-related compliance issues, analyzing proposed legislation and regulatory policies, and preparing testimony on emergent state legislation and regulation throughout the US EPA Region 9 with a focus on California. Catherine also identifies and coordinates cross-service issues to present to state and federal regulators and legislatures. In addition, she advises RegCom on strategic communications with elected and appointed officials at the federal, state, and local levels. From 2012 to 2015, Catherine served as an environmental policy advisor to Navy Region Europe, Africa, and Southwest Asia, located in Naples, Italy. She has a BA in Communications and Russian from the University of Arizona and a JD from the California Western School of Law in San Diego. And with that, I turn it over to you, Catherine.
Thank you, Rula, and thanks everyone for joining us. If you could go to slide 16, great, thank you. This is the agenda, and I'm going to go as high 30,000-foot view on all of these topics as I possibly can. I really enjoy the weeds and the details and could probably talk for hours, but I'm going to do my best to stay up at the top and just talk about the basic frameworks. First, the challenges facing the military installations, and then from there go from a national perspective, scaling down to the California state perspective, and then the local regulatory perspective. So we'll step down from there as I move forward. Slide 17, please. So military challenges. This is not an exhaustive list, but it is some of the most difficult challenges our bases that are specifically located in areas that have scarce water supplies are facing. Very few of our installations actually produce their own water. People are usually surprised to hear that, but we do rely heavily on municipalities and consecutive systems for most of our water supplies. Acquiring sustainable sources of water can be really difficult, especially, and you'll hear me talk a lot about California because that's where I'm at and that's where I mainly practice, but this does apply in other places as well. There's competing interests. There's agriculture, there's municipalities, there's new development, there's growth in population. There are a lot of competing interests out there for the scarce water resources that we have. Another difficulty the military faces is an always changing mission. Our missions and our operational commands ebb and flow all the time. And a good example is Naval Base San Diego, where we expect over the next several years thousands of new sailors and lots of new ships. We can look at the numbers and work on water conservation, but when we've got constantly changing operational needs, sometimes it's difficult for us to plan that far in the future. Aging infrastructure is something that we talk a lot about, and I'm really glad Gary is coming after me in this, because we talk a lot about how do we find leaks, how do we improve our infrastructure, how do we replace our pipes. Those types of facility-related issues are definitely challenges. Landscaping, we've done a lot of work on landscaping, but we still have a long way to go. Back in the 50s and 60s, we loved to plant grass all over the place. That's not working for us anymore, so that's definitely something we're working on. And the elephant that's always in the room, especially when you're talking about federal agencies and the military, is financial constraints. Everything's about money. We can do a lot of things, we can fix a lot of things, but we need the money to do it. Slide 18, please. So I'm going to start at the top with the national framework. Most people think that because the current focus on the drought now, especially on climate change and other issues, that we'd have significant body of federal regulation on water conservation. But it's actually not the case at all. Most water conservation frameworks, whether it's legislation or regulation, is happening at the state and local levels. From a national perspective, federal agencies do have an executive order that we look to, Executive Order 13693, which is Planning for Federal Sustainability in the Next Decade. This is where we look to for what our baseline requirements are as federal agencies. Deriving from this executive order, most federal agencies took this and put their own internal policies on compliance, much like the Department of Defense did, but the requirements derive from these minimal requirements. I also want to mention that this executive order does refer back to a 2007 statute called the Energy Independence and Security Act, and some of the requirements I'm about to talk about actually come from that act itself. So what is this EO and this executive order, and what does it mean? It has a goal. The goal is sustainability, and the core value of sustainability is conserve and reduce first. So that is the focus of this executive order. I do want to mention really fast that if you look at this executive order, it's actually more greenhouse gas, climate change related, and you'll find a lot of the regulations and legislation that I'm going to talk about actually have water as a very small portion of the overall climate change, greenhouse gas rules in place. So what does this executive order say? It has targets. The idea is to conserve. By FY 2025, achieve a 36% reduction in potable water consumption, and that's using 2007 as a baseline. So basically what it tells federal agencies is you must conserve and reduce your water consumption for potable water 2% every year from here on out, and by 2025 you shall have reached a 36% reduction. Installing water meters and using water balance data. This is important. If we can't manage our water, if we don't know what our data is, if we don't know how much we use, if we don't know how much we're losing, if we don't know where it's coming from, where it's going, how to fix it, if we don't have the data, then we can't manage the resource. This executive order calls out industrial, landscaping, and agricultural water consumption separately from potable. So there's two goals, one for potable water and one for what I'll refer to as ILA, which is the landscaping, the agricultural golf course type water. The reduction target for that type of water is 30% reduction by 2025. My favorite part of this executive order is actually the last part of it, and I think that it's ambitious in a good way. The requirement is that for any new federal building, so new construction starting in 2020 with 5,000 square foot or more footprint, we actually need to reach a net zero for wastewater and water. That's huge. And what does that mean? That means when we have milcons for military, we can actually take things like green roofs, natural hydrology, green infrastructure initiatives, things of that nature, and we can budget those into our milcon process. Without this, it's really difficult to put those types of sustainability sustainable projects into our buildings because the rules on federal construction are so tight. So that requirement actually does derive from the Energy Independence and Security Act, but it's called out in the executive order. So that's something that federal agencies have to look forward to in the future and something we can utilize so that we're building sustainable buildings. So that's the federal framework where what I'm going to talk about all kind of flows down and derives from. Slide 19, please. So now that I've explained the national framework, I want to talk specifically about California. First, it's what I'm passionate about. It's the state that I primarily work in, but it also has a really interesting history on groundwater regulation, or rather a lack of groundwater regulation, and how that affects our military installations that are located in California. We have 10 major Navy installations in California. In most of the country, and those of you that are listening in from the East Coast, you probably are familiar, there's a long history of how groundwater rights are allocated, who's upstream, who's downstream. Those things have been known quantities for decades. Out in California, it's really truly been the Wild West. In California, if you drop a well and you pull water, it's yours. There hasn't been any regulation on who gets what and what those rights look like, with very few exceptions. A lot of people are surprised to hear that, and that's great as long as you have an unlimited natural resource to draw from. In California, especially in recent history, we have a prolonged drought. Many of our groundwater basins began to go into overdraft and some into severe overdraft. Much more water is being pulled from the groundwater basins than what's being recharged and being put in. Land subsidence and dried up wells was the beginning of a huge problem statewide. So I want you to take a look at these images. This is taken by the Yosemite Conservancy at Half Dome, and it's in the Sierras, and it's taken the third week of March over the last 3 years. It's also important to note that 2014 and 2015 were the two hottest years on record for the last 121 years. California's drought is extreme. It's significant, and it's a huge problem. So there was a lot of pressure to do something. When agricultural people start dropping wells and there's no water and everything is drying up, there was a lot of pressure put on the government. So Governor Jerry Brown signed the Sustainable Groundwater Management Act, making it the first legislation that regulates groundwater in California. And basically what the bill does is it demands the local governments to get involved and to balance their water budget. Slide 20, please. So when the bill was first in draft form, the REC engaged heavily. Who's the REC? As Rula said at the beginning, our office here at Navy Region Southwest operates as a REC. So the Department of Defense designated, the Regional Environmental Coordination Office. It's tasked with representing all military services within an EPA region on environmental matters. So we here at the Navy, California is part of EPA Region 9. We represent the Marines, the Air Force, and the Army on environmental policy matters when we're talking to regulators and when we're talking to legislators. We have a united voice for all of our military services. We engaged heavily with the bill sponsors. We ensured that the military not only had a place at the table for these important resource discussions, but that the military's use of water was defined in the statute as a beneficial use of states' water. So it put us in the same category as agricultural uses and municipalities and people using water for their private homes. And that was important that that was in the statute. We live in these communities. The people who are stationed on our bases live in these communities, and it's important that we're part of the solution. I want to pause quickly and discuss the bullet on adjudication, and I will try to tone down the legalese, but the McCarran Amendment, which is found in federal law, provides a waiver of sovereign immunity, and it subjects the federal government to state adjudication when it comes to water rights. So what does that mean? That means if somebody wants to litigate a water right and they want to go to court, and there's stakeholders, and the military is one of them, it means we are subject to that adjudication. So for those basins where adjudication has occurred, this bill, SGMA, allows the outcome of that adjudication to serve as a parallel track. So for example, Edwards Air Force Base is in the Antelope Valley. There was a claim for water rights. It was adjudicated. It went to litigation. It was very complex. There was over 150 stakeholders that were part of this complex adjudication. What came out of that adjudication was a settlement. That settlement was extremely important for the Department of Defense because within that settlement, the court agreed the military has Federal Reserve water rights. That trumps and takes priority over all other beneficial uses. So the court affirmed the existence of Federal Reserve water rights and treated all of those rights as a priority. When Edwards was given their allocation of their water rights, they were given enough water to cover their current mission. They were also made an argument in court and won that they should have enough water allocated to cover any reasonable possible future missions. So they were allocated enough water to ensure that they could continue their mission into the future. So what happened was, after they got their allocation, all the rest of the stakeholders were allocated their rights based on what was left. Slide 21, please. So what does SGMA say? What's in it? What are the requirements? So the bill basically said there's two basic premises. The first is that the stakeholders in each water basin or a group of water basins have to come together. They have to create a new state agency, a sustainable groundwater agency, and they have to create a sustainable groundwater management plan. And that includes allocated water rights for all stakeholders, whether it's municipalities, water agencies, agricultural, private homes. The plan has to create a sustainable yield within 20 years. And I always explain this to people as they have to balance the budget. Within 20 years, they have to balance their water budget. There has to be the amount of water that is being pulled out of that basin must be equal to the amount of water that recharges the basin. So that's the requirement. The second premise of SGMA is that water is a precious commodity, and we've got to manage it. It's not enough to just allocate water and choose winners and choose losers. We have to take care of the commodity. We have to study the aquifers. We have to characterize it. We have to figure out new ways of recharging it. We have to manage it collectively. So that's the crux of what this bill does. So where does Department of Defense fit into that? And I'm going to go ahead and use China Lake as an example just because that's currently where the military is working its efforts right now on SGMA. Our commanding officer out in China Lake, they're out in the Indian Wells Valley, which is a severe overdraft basin. There is significant pistachio farmers, alfalfa farmers. There's huge competition for water resources, and that basin's been in overdraft for over 50 years. So all of the stakeholders came together. The commanding officer of the base participated with all of his subject matter experts. We agreed to become an associate member, which means we can't vote. We can't provide money contributions into the GSA, but we can meaningfully participate. We can send our water experts. We can do in-kind services. We can give technical expertise. And we do a lot of that, and we have done a lot of that. All of our bases across the country do this on a regular basis. They work with their local municipalities on these types of things, and we have some of the best water experts out there. So even though we can't be voting members and we can't give money, we do have a lot to bring to the table. And I always point this out for people because it's hard to explain the value of this enough. When you have a group of people who are competing for a resource and that resource is their livelihood, a lot of times people immediately say, well, I'll just sue you. We'll just litigate. Water rights litigation takes decades. Camp Pendleton has had some form of water rights litigation going on for the last 60 years. It's not easy, it is painful, and it creates a lot of broken relationships in communities. So when the military is sitting at the table and everyone is aware that we have federal reserve water rights, right, so we could participate in an adjudication and get our rights and walk away, when we're sitting in the room and we're participating and we're going to say, you know what, we're going to conserve and we're going to take our cut. There's something about that that creates trust in an environment, and we become the honest broker. And I think it's a role that we take seriously, and I think it's important. Slide 22, please, Rula. So that kind of wraps up what's going on from a legislative perspective and how we are heavily involved in how water rights are being allocated throughout California. The other thing that's been going on in California, lightning speed, is new regulation. One of the most important parts about after we conserve and we reduce is finding new resources. Well, new resources are scary for people. I don't know how many of you are familiar, but in California, many years ago, they tried a PR campaign called Toilet to Tap. And it didn't go over very well. People are concerned about safety of their water. Is it safe to drink? And there's a visual that's not pleasant when you talk about that. But the reality is, when you have such scarce resources, those are things you need to start looking into. So I'm just going to quickly go through some of the regulations that are in place now and that are being implemented, drafted, or discussed for future use. Recycled water for non-potable uses. So this is something that's been implemented well, and it's something that locally has been accepted by the community as being safe throughout California. We use recycled water for irrigation, for watering golf courses. It's prevalent everywhere. If you come down to San Diego, you'll see new construction has purple piping. That purple piping is where that water comes from. So there are significant regulatory regs in place that manage that and make sure that that is safe usage of it. Fines for excessive water use. Once it was realized that water is actually a precious commodity, the markets could work in a way that could regulate prices and they create natural conservation, right? If something becomes cost prohibitive, then people will naturally conserve. So the regulators raised the rates and put in, fines is a strong word, but it basically dissuades anybody from using an excessive amount of water because the cost of it is extremely cost prohibitive. These fee structures are currently in place, but I will say that there's a lot of pushback, a lot of people that don't like it, a lot of people that would rather see other efforts in place rather than to, in their minds, tax the people that are using the water. Wastewater for groundwater augmentation. So this is one step above using recycled water, wastewater for non-potable uses. It's using that treated wastewater and recharging groundwater sources with that water. The idea is that it has time for natural dilution, filtering before it's pulled back out of the ground and used for potable uses. Again, because the public's very sensitized to the failed Toilet to Tap campaign, anything that's using treated wastewater for a potable source is really difficult to get the community to get their arms around. So this is something that's in flux right now. We do already have permits. We do this at some of our facilities, and it is a safe and effective way to manage the resource. It's just a matter of explaining the safety to the general public. Slide 23, please. So what does the future look like? This is a list of the things that we have discussions with legislators and regulators on a regular basis. Some of them have draft regs in place, but these are things that have not been implemented statewide. Stormwater capture and recycling, it's being looked at very closely, but it is very expensive. But getting the facilities to actually catch, treat and then move stormwater during storm events is something that has been talked about a lot, but it's something that's actually really difficult to implement. The other problem with it is that the people that are at the end of the where the stormwater runoff is bear the brunt of that responsibility. So here in San Diego, we have 3 military installations, a Coast Guard, and a Coast Guard installation that ring our bay. San Diego Bay is ringed with military installations. So any regulation that would require stormwater to be captured and treated and reused, most of that would fall to the military. The cost of it, the infrastructure, the treatment of it, that would all fall to the people that are at the outlets. There's a certain unfairness about that people discuss a lot. These stormwater programs are rolling out currently, and every time we see these types of regulations, we engage with the regulators and make sure that they understand our concerns. But this is definitely something that is coming in the future. Wastewater treatment and recycling. So this is the last step in the process, right? You don't take the wastewater and you don't use it for irrigation, and you don't put it in the groundwater. You actually put it in surface water, or you reroute it for use directly. This is toilet to tap, and there are companies working with the regulators right now who want to make this a reality. I think we're still several years out from convincing the general population that it is safe to drink treated wastewater. So that's something we're struggling with and will continue to struggle with. I'm going to actually take a few minutes to talk about desalinization because I think it's important, especially with the Navy. We get asked all the time, you guys are experts at desal. All of your ships have desalinization. That's how you produce your water. And desalinization is absolutely on the horizon. The problem is the energy consumption. So here in San Diego, we have a brand new desalinization plant. It's called the Poseidon plant. It's up in Carlsbad, where we had a former energy facility that used to be there. So a lot of the infrastructure was kind of sort of in place already. That plant took 15 years, and I've heard upwards of, I won't say a number, but a big number, just to obtain permits. There are significant environmental considerations when you're talking about desalinization, the effects of the marine life when you have intakes. What do you do with the brine discharge? These are significant hurdles to overcome. The Poseidon plant went online December of 2015. It produces 50 million gallons a day, so it's enough for 400,000 people locally, provides them enough water. So the biggest challenge, one of the biggest challenges aside from the environmental effects of that plant, was the requirement that California gave them. If you're going to build a plant, it has to be net zero energy. Desalinization takes a lot of power. So to have a net zero desalinization plant, a lot of people feel like this is the future. This is the future of a drought-resistant water supply. So the plant's online. It is working at net zero energy. They have a cogen plant. They have solar panels on every square foot of the facility. It's actually a very impressive facility. The technology is actually moving into the future with less and less need for such energy. They're becoming more energy efficient. So and this is just me personally talking now from what I've seen, I do think that very quickly in the future we will see desalinization become a more regular form of water production, specifically along coastlines. The State Water Resources Board has put this on their priority list of draft regulations to promulgate over the next couple years. The Poseidon plant was done and permitted locally. So what the State Water Resources Board wants to do is to provide statewide guidance that all of the offices can use so they've got consistent compliance when it comes to these facilities. So next, slide 24, please. So I'm going to move away from regulation and legislation and move into what's the military doing? What are the military initiatives? it's important to understand that anything that the Navy has in place, whether it's from OSD or SecNav and down to Navy Region Southwest Water Strategy, which I'm about to talk about, we meet or exceed anything that is already in current law. So any executive order, any state mandate, anything that's on the books, that our policies meet, or what we say meet or achieve those goals. We are out in front of this. So the Navy Region Southwest Water Strategy was signed by our regional commander in 2015, and what it says is we're going to have a 25% cut in water consumption by 2020, which is 10 years earlier than most of the other rules that are out there. We're going to do it in 5 ways. We're going to create a culture of conservation, and you'll see on the next slide when we get there. We did a massive PR campaign. We had figures of how do you take a Navy shower, and they were plastered all over the locker rooms on all of our bases. We had MWR facilities that put up shining light blinking, save water, every drop matters. Our MWR facilities only serve water if somebody asks. We put all of our BQs and hotels, requesting only for laundry services. We did a full court press to create a culture of conservation. We put money into water conservation projects, compliance projects, including things like fixing, where we knew we had leaks, where we knew we had water loss. Irrigation and landscaping, we put in a lot of turf. Water data acquisition, we've got to work on getting better data. So we actually achieved, for our goal was 2020. In 2012, we had done most of this work already. We put 225 waterless urinals in place. We put in ultra-low flow toilets. We had new shower heads, new faucets. We zero-scaped. We put turf everywhere. We put desert landscaping. We had winter irrigation shutdown policies. This program is working. The Navy is doing a very good job at reducing their water conservation. It's something that we're very proud of. Slide 25, please. So this is just a visual. I love the Navy shower, save the water, and you can't walk into a locker room without seeing this everywhere. And it's interesting. We did some competitions on our bases to see who could conserve the most. And when you ask, specifically sailors, when you ask them to do this, it's amazing that they perform, and we did very well. We do a very good job conserving water. Slide 26, please. So I'm going to end this here. In conclusion, water conservation and sustainability is a priority. We put a lot of man hours towards it. We put a lot of man hours working with our legislators, with our regulators, and working with our bases and our sailors. We have to continue to do that for a long-term solution. Everyone thought El Nino was going to save California, and it didn't happen. And it's not going to take a one good rainfall year to save California. There needs to be a long-term plan in place. And financial investment is critical. It's important that we put money into our facilities, and it's important that we lead on innovation. And Gary's going to talk next on some of that innovation, and I think that's the way of the future. So thank you very much for your time.
Great. Thank you so much, Catherine. We've received a number of questions for you. So I'll pose the questions, and if you could please answer them, we'd really appreciate that. This is a question from Lockheed Martin. Do the 2007 Energy Independence and Security Act and Executive Order 13693 apply to government-owned, contractor-operated facilities?
That's a really good question. The answer is it depends. And the answer is also that those decisions are usually made locally. We have a lot of attorneys spread throughout all over the government here, and typically what happens when we get in a project, that when we decide what requirements it has to meet, that command specifically will decide whether or not those requirements apply to what we call outliers, like these contracting facilities. typically the position is if the money is being funded for a federal purpose through a MilCon or through any other where the money is coming from, we follow the money and we look to that. So typically I would say yes, but there are exceptions, and I would ask you to please go, talk to your attorneys at the commander and who's dealing with it to get an answer.
Thank you, Catherine. A question about the desalination plant that you talked about. Can you elaborate on whether it is operating at net zero or designed to be net zero?
I knew someone was going to ask that question. So it is designed to operate at net zero. It has been online for about 6 months, and they're getting ready to kind of release their statistics and standards and determining whether or not they actually have been operating at that level. And so that's something that's in work. They haven't been online for very long. They are designed to operate at net zero. So it's to be determined whether or not they have met that requirement.
Thank you for the clarification. You stated that DoD's Regional Environmental Coordinator works with legislators to ensure the military is considered in legislation. Do you also engage with regulatory agencies on new water regulations? And if so, does the Navy coordinate with other military services?
So absolutely, the answer is yes. We have very good relationships with all of our regulators, the State Water Resources Board, our regional water boards, and frankly all regulatory agencies, even from ARB, DTSC. We engage with them regularly. We know their legislative directors. We know their staff. And a lot of times they will reach out to us even before they promulgate draft regulations for a look at whether or not there's things in there that we're concerned with or that we have issues with. I get the question a lot about the Navy representing the other services. We have a team that includes the Air Force, the Army, the Marine Corps, the Coast Guard. We have regular facilitated calls with them. Whenever we take an actual military position, whether it's a bill or regulatory, we have full buy-in from all of the services. So when the Navy goes out and engages on these things, we're going in with full buy-in from all of the services. It's actually a very well-oiled machine and something that works very well.
Thank you, Catherine. If the military has Federal Reserve water rights, why do you participate in SGMA? Why don't you just educate water rights everywhere we have a base in California?
So, in a perfect world, we're the federal government, and we can participate in adjudication and say, all the water is ours, and you guys can live with what's next. But we live in these communities, and like I said previously in my presentation, adjudication is not easy. It is decades and decades, and what happens over those decades is you create very negative relationships with the city council, with the water municipalities. You create this very antagonistic relationship. Our purpose and where we are on our bases and why we decided that we should fully participate in SGMA is we have long-term goals. Our base in China Lake, hopefully will still be there in 100 years. We have really important missions. We have long-term relationships that we need to keep with the cities and with other agencies. So we made the decision that it was really important that we were part of the solution and that we continued to support California in its way forward.
Thank you. And maybe a question that's a good segue to Gary's presentation. Can you comment, or are you aware of ways that DoD supports technological innovation to promote water reuse, reduction, and conservation? Can you comment on that, please?
Yeah, and I think Gary's a perfect person to segue into this. The military spends a significant amount of money on RDT&E. XWIC, the command that's here in California as well. I've seen projects that are, not desalination where they're pulling water and they're trying to use the water from that. I've seen R&D projects that, pull from the air, pulling water from the air and creating water from, condensation. I've seen projects like what Gary's about to talk about, where using technology to find things that we couldn't find in the past, like leaks. We talk a lot about desalinization as well. Nobody does it better than the Navy. There's been a lot of scuttlebutt about Camp Pendleton wanting to do some desalinization, and a lot of it is around water security. How do we get a source of water that is secure, that we know will be there long term? And desal, more and more, is coming to the forefront of that. I'll go ahead and, when Gary has his talk, I'm sure he'll touch on technology, but a lot of money, DoD spends a lot of money into technology.
Thank you so much, Catherine, for a fascinating presentation. The next part of the webinar will be presented by Mr. Gary Anguiano, who's the Water Pollution Team Lead for the Environmental Security Technology Development Branch of the Naval Facilities Engineering and Expeditionary Warfare Center in Port Hueneme, California. Gary is a principal investigator of projects involving demonstrations of advanced acoustic sensor technologies for detecting leaks in potable water lines, the development and validation of stormwater treatment systems, assessment of water conservation technologies for landscape irrigation, and also application of internal epoxy coatings to repair leaky compressed air lines. His past projects for the Department of the Navy include development of rapid repair methods for war-damaged fuel and water lines, development of portable depaint and paint maintenance facilities for military helicopters, development of aircraft wash water recycling systems, and civil engineering support on short-based bilge and oily wastewater treatment systems for wastewater from Navy ships. Mr. Anguiano is a co-inventor of 2 Navy patents. He has a bachelor's degree in civil engineering from the California Polytechnic State University. And with that, I'll turn it over to you, Gary.
Thank you, Rula, for the introduction. This is Gary Anguiano from the Naval Facilities Engineering and Expeditionary Warfare Center here in Port Hueneme, California. And good afternoon, all in the West Coast, and a good morning to you all on the West Coast. Today's discussion will focus on results of testbed and field demonstration of acoustic sensor technologies on DoD water distribution systems. The technologies were evaluated using quantitative and qualitative performance criteria. The demo was conducted at Vicksburg, Mississippi at the Army's Engineer Research and Development Center, or ERDC for short. This project was a joint effort with engineers from NAVFAC, XWIC, ERDC, and Petrol Memorial Institute. Slide 30, please. Okay, this is our agenda slide. It outlines the talk for today's discussion. We will review the drivers behind this effort and the growing need to conserve water. We will discuss the fundamental operations of acoustic sensors linked with cross-correlation software to pinpoint leaks in pipelines. 2 types of acoustic sensors will be discussed. The bulk of the time we will be used to discuss the results from the demo. We will finish with conclusions and follow up with questions and answers. Again, please note the disclaimer at the bottom. In summary, it states that the NAVFAC or Navy does not endorse any of the discussed products, and the presentation is informational only. Slide 31. The importance of leak detection for DoD water conservation is highlighted by the fact that drinking water distribution systems are typically 50 to 75 years old. And just like me, they're ready for retirement. On average, there is 1 break every 4 miles of main line per year. EPA estimates an average of 14% water is lost due to leaky pipe systems, and $250 billion is needed over the next 20 years to repair and replace our aging infrastructure. Meanwhile, recent droughts in the southwest region have been the most expansive in decades. The risk of drought, increased water demand, and evaporation will only intensify as climate changes over time. In response, the President has ordered to to reduce water consumption by 36%, as we heard in the last presentation. And this will be no easy feat. Part of the solution is to repair the leaks in a timely manner to conserve water. First, leaks must be detected, located, and prioritized for repair. To effectively accomplish this, DoD needs a detection system capable of locating leaks within a 4-foot window in a wide variety of metallic and non-metallic pipes. Slide 32, please. As mentioned, the elephant in the room, due to the budget constraints and the relatively low cost of water, it has been common practice to manage leaks using a reactive approach, which is to wait for reports of surface leaks or observations of high water usage. State-of-the-art acoustic technologies with cross-correlation like the ZoneScan Alpha allow for continuous remote monitoring with a network of 3 to hundreds of sensors, while the leak finder and Korra Lux devices allow for episodic inspection with 2 sensors and mobile correlation devices. The project objectives were to validate the product's ability to detect and locate simulated leaks in challenging pipe types in the confines of a test bed, and secondly, to detect and locate leaks on an operational water distribution system. I wanted to introduce our tech transfer person, Kyle Lawrence, who will take on a few of these following slides. Yeah.
All right, Rula, would you please change to slide 33, please? Acoustic cross-correlation works by correlating signals and measuring leak signature transit times to determine the distance of the leak from the sensors. When a pipe leaks, a unique sound travels from the leak through the pipe material and the water. Acoustic sensors attached to the pipe or the water column can detect this leak signature. If the sensors are on either side of the leak, the difference in the transit time of the sound waves can be correlated to the difference in distance between each of the sensors and the leak. To accurately predict leak locations, pipe diameters and materials must also be known, as these parameters affect signal transit. Acoustic leak detection technology has been around for some time, but in recent state-of-the-art developments have enabled it to be used more effectively with longer sections of non-metallic pipes such as PVC. Such developments include automation, noise filtering, and other advanced data analysis techniques. Slide 34, please. We evaluated 3 leak detection technologies that claim to be able to detect leaks in challenging pipe types like PVC. One of the 3 technologies was the continuous monitoring system called the ZoneScan Alpha. It automatically collects acoustic signals from a sensor network each night to detect and locate leak signatures. For 2 hours each night, each synchronized sensor captures and stores acoustic data and sends it to a server for data processing. The measurements are made at periods of low water use as the distribution system approaches static conditions, and there are fewer sources of interference, such as opening and closing of valves. The server conducts cross-correlation to detect and pinpoint leaks. End users can review graphical information each day to evaluate potential leaks in their water distribution system. Sensors shown in red in the diagram shown have potential leaks. The software provides the leak distance from the red highlighted sensors. Repair crews can be dispatched to the predicted location to confirm the leak with above-ground listening devices. Slide 35, please. The second technology that was tested was the Leak Finder RT system. Base personnel can procure the devices to conduct surveys, or leak detection service may be acquired from the vendor. The system correlates signals from 2 sensors that are temporarily installed on hydrants, valves, or pipe surfaces. The sensors, also known as accelerometers, are moved to different locations allowing leaks to be detected in the pipe segment between the sensors. The technique is informally known as lift and shift. This configuration is designed for intermittent inspection, which is typically recommended every 3 to 5 years. This product uses a laptop and 2 accelerometers to determine the presence and location of a leak, the pipe interval being monitored. The technology can also use hydrophones in lieu of accelerometers to detect leaks. Hydrophones detect sound traveling through the water column rather than the pipe material. These sensors can be used when military installations allow contact with the water column at fire hydrants access ports. Slide 36, please. Korra Lux is the third technology we evaluated. It is also a lift and shift system that uses accelerometers placed on valve boxes or fire hydrants. Unlike the previous technology, a dedicated correlation module is used in lieu of a laptop computer. This technology can be procured for in-house use with properly trained technicians or acquired as a service. This product was recently implemented at Toby Hanna Army Depot in Pennsylvania to monitor their potable water system. Please advance to slide 37, and I'm going to pass it back to Gary.
Thanks, Kyle. Performance objectives. We developed quantitative and qualitative performance objectives at the onset of the project to support validation of the technologies. The objectives were based on engineering judgment and discussions with personnel from public works departments. The objectives focused on confirming the ability of the technology to detect the presence of a leak greater than 1 GPM, pinpoint the leak within plus or minus 4 feet, and minimize false positives. From a cost perspective, the savings to investment ratio should be greater than 1 to justify procurement of leak detection service or procurement of equipment for in-house usage. Let's advance to slide 38, please. This is a schematic diagram of the underground PVC and ductile iron piping test bed established at ERDC in Vicksburg. 3 risers were installed to simulate fire hydrants and for above-ground attachment of the sensors. Leak points were installed throughout that could be turned on or off from above ground. Hydrostatic tests were conducted with all the simulated leaks in the off position to ensure that there were no other leaks present other than the simulated leaks. Tests were conducted with flow moving through the pipe system at 24 gallons per minute in lieu of simple static conditions to simulate extraneous noise that could occur during a leak survey. Slide 39, please. Varying size orifice plugs shown in the center photo were installed on the pipe segment of the test bed and were buried and connected to the water supply to simulate the leaks. The orifice plugs were threaded into a corporation valve, which is shown on the left, and that was tapped into the 6-inch diameter pipe. A T-handle controlled the on and off valve position of the corporation valve for the leak simulation. This pipeline was buried with 30 inches of native soil. The leak configuration was approximately the same configuration used in previous leak assessment studies conducted by Petrol for the EPA. 11 artificial leak points were installed ranging from 1 to 8 gallons per minute at 90 psi. The flow rates of the simulated leaks were determined using Greeley's formula and validated before installing below ground. In addition, flow rates were validated with a low flow meter once the test bed was buried. We included a lateral near the middle of the pipe run with the leak about 10 feet down this lateral to see how well the technologies could deal with a leak removed from the main line, which was bracketed by the sensors. This test bed was 200 feet long and was built by the Public Works Office at ERDC. Slide 40. The results of the test bed evaluation are presented here in this table. The cells highlighted in green met the established performance objectives. All the products except the leak finder hydrophone detected the presence of all of the leaks. The Korra Lux device met the performance objective of less than 5% false positives, meaning it didn't predict a leak where there was none. Only the leak finder accelerometer located all leaks within 4 feet. The Korra Lux technology met the majority of the performance objectives with only 1 missed leak location. The ZoneScan Alpha missed only 2 leaks. All the products detected leaks as small as 1 gallon per minute. Slide 41, please.
From our test bed results, we found the following. The best location accuracy was achieved when no more than 1 leak was bracketed with sensors in the same type of pipe as the leak. When 2 or more leaks were active in the same bracket, correlations were not as accurate as there were when only 1 leak was present, even when the leaks were in the same pipe type. When hydrophones were used, leak detection was acceptable, but leak location was diminished. Slide 42, please. A field test on an operational water distribution system was also conducted at ERDC in Vicksburg, Mississippi. Several pipe sections in the water distribution system were selected for inspection based on coverage of a wide range of pipe types, including PVC, ductile iron, and asbestos cement. Over 2,000 feet of pipeline was monitored over a 2-week period with 20 sensors installed. 1 pipe section had a known leak and was included in the assessment. The screenshot seen here shows the ZoneScan Alpha system's output from a monitoring event on July 22, 2014. A leak was observed between 2 sensors represented by the red sensor icons. As shown on the left, the ZoneScan Alpha correlates the distance from the sensors. We validated the presence and accuracy of the ZoneScan correlation. The Public Works Office dispatched a crew to validate the leak with a listening device and made the repair. Slide 43, please. The location of the leak was correlated to be 81.5 feet to the west of sensor 7 and 182.1 feet east of sensor 6. The location was investigated by Petrol and ERDC Public Works staff, and a valve was found in the vicinity of the correlated leak location. When the lid of the valve box was removed, the box was found to be full of water. Based on the distance from sensor 7 to the correlated leak, 81.5 feet, and to the valve, 77.2 feet, the valve was believed to be the source of the leak. The leak was later stopped by tightening the valve. The correlated leak location was within 4.3 feet of the valve location. Slide 44, please. Leak Finder RT found 2 suspected leaks or points of interest, referred in the chart here as POI. The Leak Finder RT predicted a 60-gallon per minute leak and an 11-gallon per minute POI within the ERDC distribution system. The vendor estimated water loss to be 101,000 gallons per day at a value of approximately $104,000 per year based on the local water rate of $2.80 per 1,000 gallons. Slide 45, please. A leak was apparent due to the presence of standing groundwater. the leak finder RT predicted the location of the leak to be on the water main near the building, but when excavated, no leak was found. The leak appeared to be under the foundation of the building. ERDC Public Works staff turned off the water to the building and the leak stopped. The base plans to abandon the line under the foundation and to install a new line. Slide 46, please. The performance objectives for the field testing at ERDC could not be fully evaluated for a number of reasons. First, the test plan called for the identification of 5 leaks for verification, but only 3 leaks were identified by 2 of the technologies. Secondly, only 2 of the technologies could be compared at the same time and in the same location. Those technologies were the Leak Finder RT and the ZoneScan Alpha. The Leak Finder RT identified 2 of the 3 leaks, but as discussed in the previous slide, 1 leak appeared to be under a concrete slab of a large building, so the exact location could not be verified. The other detected leak was found under a paved street near a large test facility. When ERDC Public Works inspected the leak several weeks later with ground microphones, they did not detect a leak, nor did they observe any evidence of a leak. It is possible that the sound from an open faucet in a nearby building could have indicated the main line had a leak where the building's water line connected to the main line. The Public Works staff decided not to excavate due to the lack of evidence, and therefore the accuracy of the detector could not be verified. The remaining leak was identified by the ZoneScan Alpha in a valve box in the proximity of the second leak identified by Leak Finder RT. Since this was the only leak identified by both devices, the performance objectives for the field test could not be fully evaluated. In addition, the Korra Lux field test was conducted at a later date and could not be completed in the same area due to road construction above the targeted pipelines. Slide 47, please.
Thanks, Kyle. Our conclusion slide. Our overall technology performance conclusions were that all the accelerometer-based sensors met the leak detection objectives. The location accuracy was dependent on several factors. For accelerometers, the leak location accuracy varied from 86 to 100%. For the hydrophones, 50% leak location accuracy did not meet the performance objective. Accuracy was found to be a function of pipe type, number of leaks, and number of leaks present. Accuracy is degraded if the sensor brackets 2 different pipe types. The potential for false positives exists based on the data. However, all vendors recommend a follow-up validation with an above-ground listening device, ground microphones, even the Korra Lux technology, which had no false positives. We recommend, next slide please, slide 48. We recommend that installations conduct intermittent inspections on a 3 to 5 year interval on their water distribution systems. Conservative estimates of water loss indicate high savings to investment ratio values for all technologies. They can procure the equipment if Public Works personnel are available or procure the service from a vendor. Slide 48. Excuse me, Bob. 49. As highlighted in our final report, leak detection using continuous monitoring technology offers potential savings to investment ratios greater than 1. The primary benefit of this technology over intermittent inspection is higher potential for reducing water loss, as leaks can be identified and repaired more rapidly. Although non-DoD entities are adopting this next generation technology, barriers and issues with securing data transmission and IT security approval preclude widespread use within the DoD. We believe in time, though, that these issues can be resolved. To maximize water conservation, leak detection technology should be integrated with advanced metering infrastructure, pressure management protocols, and water balancing protocols known as district metering areas. In other words, we need to know how much water is flowing through our pipelines, and they have to be validated and verified. ERDC testbed is available for future validation of any emerging technologies as required, and they plan to continue having that system for military applications. I want to thank our team members from the Army, Vic Medina and Scott Weisner, and from our Petrol partners, Wendy Condent and John Matthews. Thanks for listening in, audience. And at this point, I think we open up for some questions.
Yes, thank you, Gary, and also Kyle. We received a number of questions. The first one is from the Navy. Can you please elaborate on the cost per mile for ZoneScan Alpha?
The cost per mile for the ZoneScan. I don't have that data right in front of me. The final report will have that information. I believe the final report will be published within a couple weeks. A couple months. It's in the final stages. It highlights the cost by the amount of leaks per mile. I think there's 4. We estimated that there's 4 leaks, or 1 leak for every 4 miles of pipelines. That's kind of the going theory on predicting leaks, and it probably increases as the pipes are older and metallic and in corrosive soils.
Thank you, Gary. And for everyone on the phone, you can refer to this website at a future date to download a copy of that report. A question from EPA. Our first speaker, Catherine, said that it is rare for DoD to have its own potable water system, and that DoD mostly relies on municipal systems. Are the leak detection technologies that you use, Gary, only on the DoD-owned portion of distribution systems, or are these technologies at some point going to be available to assist municipalities that may not have the financial means to develop such advanced detection technology?
Okay, the question ties in. The Navy has privatized communities that have jurisdiction to some of the water components within a naval installation, but the main lines from within the fence line are managed by the Navy. They have to repair those, so the technology can be applied even though the source of the water is from outside sources.
Thank you, Gary. Can you please tell us what the maximum distance for a sensor should be to detect a 2 GPM type leak?
Well, our studies focused in from anywhere between 1 to 8 GPM. 2 GPM wasn't exactly, but if we assume at 1 GPM, the Korra Lux technology was able to detect a leak, a 1 GPM leak on a test run at 200 feet.
Thank you. As a follow-on and a clarification to your earlier answer, this is from the Marine Corps. Are you recommending that water systems at installations that have been privatized be investigated for leaks?
Well, one of the earlier goals of the project was to investigate the integration of leak detection with advanced metering infrastructure, and we found out that that the AMI had been implemented at a number of DoD facilities, and their technology, their hardware and software technology, was compatible with the ZoneScan technology. And had we been able to secure approval, we could have used their technology to send data and have it processed together. Main lines and service lines was our goal. And I think, the future may hold that promise, but we need to be pretty forthright in thinking the future requirements for AMI. Maybe there's a way to integrate the leak detection in that partnership.
Great, thank you. Can you please tell us what the projected service life of the sensors used in continuous water monitoring systems, what that projected service life is?
Yes, the batteries on the sensors last for 5 years, unless you have impact or really aggressive environment that the sensors are in. The sensors should last between 15 to 20 years based on the reports from the vendors. They make them in aluminum or stainless steel, depending on how aggressive the environment is. So unless they take a direct hit, a headshot, they should last a while. And but they will have to be watched every 5 years. The ZoneScan has a maintenance tab in their programming that allows you to look at the battery charge of a given sensor. So that'll help you do maintenance.
Great, thank you. One last question before we pull Catherine back in, Gary. How well did the technologies you tested pick up the leaks on the lateral test bed?
That's a good question. They did pretty well. We had a variety of leak size established on the lateral, and in all cases it detected the leak. One technology was a little better in determining the location of the intersection point where the lateral met with the main line. Did pretty well within the established performance objective of 4 feet.
Thank you. And Catherine, just to get you back into the discussion, can you comment on how well conservation measures and PR campaigns working for the military in general beyond the Navy? And can you comment on whether you think DoD will meet the goals that you described in your presentation?
I've seen a couple presentations from the other services, but I can't speak for them on where they actually are with their goals. When we started this campaign, we saw huge successes immediately, and the things that are easy, and the Navy showers and the reduction in use, that's the low-hanging fruit. That's where you're going to get your first chunk of successes. Moving forward from that becomes a little bit more difficult, looking at things like landscaping and improving facilities and doing some of the things that Gary's talking about, trying to figure out where our leaks are. Can we loop systems, which we just did at Coronado to fix some of these issues? So those are smaller bites at the apple. I will say from the Navy statistics, we do believe absolutely, yes, we will meet our goals. We are on track, and we will be doing it. I have seen presentations from other services that they are also on track, but I can't speak for them. I don't know what their final numbers look like. But for the Navy, yes.
Thank you so much, Catherine. Gary, beyond aging infrastructure, what do you think are other contributors to leaks?
The aging infrastructure, usually it's all about corrosion and the burst pressure or the pipe rupture pressure getting lower as it ages. The corrosion is the biggest one. Pressure surges will create those problems. So we need to be able to dial down our pressure as we reduce or as we reduce the water consumption, it has a tendency to increase the water pressure, and when you repair pipes, it also will have a tendency to increase the pressure. So we have to develop management programs, pressure management program, to start dialing it down to minimize the potential for follow-on leakage. Other things that are problematic for pipelines is surface overloading and settlement that they talked about, like we were talking earlier, subsidence, and just the ground is moving, and joints and gaskets, they deteriorate and they move as well, and they create leaks.
Gary, a follow-on question for you. How well will these technologies work if you have multiple leaks in the same pipe segment?
How well they work? That's one of the big questions, because when our first battery of tests, we put multiple leaks on each of the pipelines. We had the ductile and the PVC, and we ran our tests with each of the two technologies, and the numbers, they detected the leaks, but the accuracy was all over the map. Very few met the performance objectives. So there's something to be said about if you find a leak, or the system detects a leak, and you find that the leak is not there, it's a good chance that it's either on a lateral or there's multiple leaks going on. So you should probably plan on using a ground microphone throughout the entire pipe segment as a strategy if you're detecting a leak and the location is not accurate or false positive.
Thank you, Gary. And a question for both of our speakers. If you could tell us what, in your opinion, is a single technological innovation or policy change that can help DoD achieve its goals? One, for reducing leaks, that's for you, Gary, and two, Catherine, for reducing water use. And let's start with Catherine, please.
Technological advance. I think water reduction comes down, it's not going to, I don't think that we're going to be saved by an innovation unless the military moves forward with, putting desalination plants on all of our bases to have our own secured water source and upgrades our infrastructure. I think short of something extremely drastic like that, I think it's going to come down to something that's frankly boring. It's putting money into new piping, into leak detection, into new infrastructure, and to continue the PR campaigns. I don't think that there's a way to use technology to get from A to B without it being extremely drastic. I think it's going to be the day-to-day measures that get us to where we need to be.
Thank you, Catherine. Gary?
The room that I'm in had a little bit of a noise issue, so I didn't quite hear the comment. But I think in terms of what we need to be looking at in the future, as we conserve water and meet our goals, our 36% reduction, we got to be careful what we ask for. When we reduce the water through our pipelines, we don't have the same amount of flushing that's going on. We have bacterial growth that will stay in our pipelines longer. More chlorine might be required. Like we mentioned, with increased pressure, that may create more problems down the road. Our infrastructure could be impacted by that. You look in the news all the time now, where everybody's conserving water, and you see all these bursted pipes more prevalent. So that's part of the constraint or part of the problem. So we just got to be careful. We're looking at some advanced pressure regulating valves to adjust to those changes, and we hope that some future R&D money will come our way, and we can test it at Vicksburg.
Great. Thank you so much to both of you for a very informative duo of presentations. At this point, I would like to mention that our next webinar is on Thursday, July 28th, and it will focus on geophysics. This webinar will feature 2 presentations by Carol Johnson and Fred Day Lewis, both from the United States Geologic Survey. Registration is open for this webinar, so please make sure to visit the CERDUP and ESTCP webinar webpage to register for this and other future webinars. Before we conclude, I would like to remind everyone that the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it at this point if you could please take a moment from your busy day to complete the very short survey that will pop up on your screen at this time. This concludes today's webcast. Thank you for your time.